All right, so I've got a student who feels uncomfortable. I may be misreading what she said, but I think she's uncomfortable with this mechanism from Lab H. So here's the mechanism from Lab H. And as I said in a announcement on D2L, there's some mistakes in here or some omissions, mistakes or omissions, and you can't put this mechanism as the mechanism in your lab book because it doesn't entirely make sense. So let's look for the first omissions. In order to do this, first mistake or omission, you always have to keep in mind that all mechanisms must have must account for all atoms and all electrons and all electron movement, right? That's what a mechanism is. How do you spell movement? Movement, okay, all of it. So let's start with the beginning. Let's start from the beginning. I'm going to add another layer before I do here, and let's go with a different color for a second. And let's say, what class of compounds is this? In what class of compounds does this thing belong? I'm going to ask you some questions. You need to try to answer this. So, do you recognize this as an alcohol? Alcohol. Very good. Okay. Now, in what class of compounds is this? All right. This is not an organic compound. If X typically stands for chlorine, bromine, or iodine. Sometimes it also stands for fluorine. It never stands for astatine because astatine is synthetic. So essentially what this means is it's a halogen. Okay? So if that's true, you may remember that ClOH is an acid. Actually, we don't write it like that. We write it like HClO. It's an acid, and it's hypochlorous acid, okay? We did this in Principles of Chemistry. Really, we didn't draw it like that. We drew it like this. In Principles of Chemistry, and we named ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus. Remember that? Okay. So I'm about to get rid of this. It's going to get really busy here, okay? So we have an alcohol here. We have an acid here, but it's a weird looking acid, okay? It's essentially, in Lab H, it's the acid that's in bleach, all right? In what class of compounds is this? It's kind of a joke, I guess. This is water, right? In what class of compounds is this? I don't know. Okay. What is this? This is acetate. You should look this up. If you don't know something like this, don't just stare at it or don't give up or don't say I can't do it. You should Google this, right? This is acetate. And acetate looks like this, COO minus, right? Which is sometimes abbreviated as ACO minus, okay? That's acetate. It's the conjugate base of acetic acid, right? Okay. In what class of compounds is this? Well, that's not a compound. That's just a proton, right? It's the currency of an acid. Okay, what is this? This is the carbonyl, right? This is a protonated carbonyl. There's water again. Here's I know this is killing some of you. Protonated carbonyl. I think it's important for context, though, right? We need to demystify these guys. Part of the problem in organic chemistry is students look at these things sometimes and just think it's all the same. It's all a bunch of Greek when it's not. Okay, what is this? Well, that's a proton again, right? What is this? That's a hydrate. Okay, and what is this? This is a carboxylic acid, okay? All right, so look what we did. We took an alcohol to a carboxylic acid. And we did this in class by using chromic acid, CH2CrO4, okay? Chromic acid. And we showed a couple different ways to make chromic acid. So the reaction from an alcohol to a carboxylic acid has a couple different forms, a couple different ways we looked at it, but I think there were 3 of them, I think, and they all 3 essentially came down to being chromic acid. All right, so let's get rid of that layer, and let's go back to the question at hand. Where are all the atoms? And there's a couple atoms missing here, and this is an accident. I think I can go back and fix it. But in the meantime, you shouldn't put something like that doesn't make sense in your lab report. And so that's why I'm doing this video, is to help the students who have looked at that carefully and are saying, wait, something's wrong here, okay? So what's the first thing that happens here? We see that a new bond is being formed between that oxygen and that halogen, right? So what we have going on here is hydroxide is being left, right? And that hydroxide is coming along and taking that proton, right? So there's really 2 steps that are here. They're implied by showing that, okay? So you can't have this as your whole mechanism because it doesn't show everything. So this hydroxide is being formed, a new bond is being formed between that oxygen and that halogen, and then this hydroxide comes in and takes water. So let me make another layer here. Let me come over here and bring that layer down here. Let's come to this layer. Let's get rid of that layer and that layer, and let's make a new mechanism. You know what I'm going to do? Since I'm going to say that we have some R group C right? Okay. Now I'm going to flip back and forth from time to time. Let me go back over here to this for a second. Yeah. Okay, so you see what I did? I took that, the first CH2 off of that R and made it, and showed it, okay, and made a new R. All right, you can call that R prime if you like. All right, so let's get rid of that. And this is going to come to an acid, which is XOX, okay, or H. So this guy comes here. Oh, whoa. That's not what it does. This guy comes here. Boom, right? And this guy comes here. Boom. And that makes RC. You see that? Okay. So they switch partners. You see that? Okay. Now let's come back over. Let me get rid of that. Come back over here. Now that we've got that new guy, we've got acetate that comes and abstracts a proton. Okay. So let's go back over here, and we've got acetate. Okay, this comes and abstracts a proton, and this comes here. Oops. Is that what's going on here? And that halide goes off by itself. That's right. Okay. So where are we? Let's get rid of that. Come back up here. And then when that happens, this halide goes off by itself. It's a halide now, not a halogen, right? Okay. So now that I've got that, can you see I've got a new bond that's formed here. You see that? We'll disappear the water now. That's just going off in solution, okay? I don't want to account for that anymore. And I'm going to say this is plus acetic acid, okay? Which I think we're not going to account for that anymore either. Let's go ahead and circle that. So we don't care about that anymore. Okay, let's come back over here. Okay, so now we've got our carbonyl compound, which I just showed, okay? Now the carbonyl compound is going to get protonated. I guess we should leave the acetic acid back on there. Wait, where am I here? You see, I've got, oh, it doesn't show where this proton comes from, but let's leave it there with the acetic acid, okay? I'm going to keep this in black. This is my acetic acid. It's the same thing, right? Okay, now that we've got that, the next thing that happens is this guy gets protonated. We're going to spend a couple chapters later this term, and that when that gets protonated, that goes back off as acetate, okay? We're going to spend a couple chapters this term. I think we're done with the acid. Let me come back over here. Yep, boom, that gets acid. Yeah, now it's going to be water that comes in here. Okay, and makes a hydrate. All right. This is something we're going to see a lot. It's going to be super helpful that we started at, where am I here? I've got to get rid of that. Okay, we're going to protonate that, and when we do, water's going to come in and attack it. You see that? So we protonated it already, okay? Now let's say we're not going to account for acetic acid anymore. Acetic acid, we're going to ignore that now, and we're going to bring back the water in, which is here. Okay? And the water is going to bump. You know what I'm going to do? I'm going to do that in black. Pardon me. Salcom would never do this. He would never do this. Okay. Okay, and this has got a formal charge of +1 on it. Formal charge is going to be very important to help you keep count of everything. So now that we've got that, I think what's going to happen is we're going to lose, just a minute here. Yeah, we're going to lose a proton. Yeah, lose a proton here. I guess it's going to be acetate that does it. It doesn't see, we're not even shown how or why. Let me go back over here. So you've got some base, which I'm going to say is probably acetate. Okay. Just comes and abstracts that proton, leaves those electrons there. I'm not sure how much more space I'm going to need, so. Okay, and this is the hydrate. Let me do that in blue. That's a hydrate. Go back to black, come back over here. All right, so we got our hydrate, right? Now I'm putting, you've noticed that in all of these, and as it says at the beginning, I don't like using an R because you don't know what an R is, right? Okay, so this final step from here to a carboxylic acid, the write-up tells you this is done via an E2 mechanism, but it's outside the scope of what we're prepared to do right now. So this part, this actual mechanism, I want you to skip. No mechanism for this step right here, right? Because that's going to take, can you see what's going to happen here? We're going to lose this, let me point this out, but you don't need to put this in here. We're losing this, and this is going to go here, which is going to go off as a hydride, which of course is impossible, right? We're going to have some elaborate mechanism for that, and these guys are going to go here. And so this is going to go off as a hydride. This is going to go off as an H plus in sum. That's what's going to happen. And so that's clearly going to require an elaborate mechanism, which I'm going to ask you to skip for now. Okay, hopefully that's helpful. Good luck.